Okay, so today we will talk about a new kind of number, but let's start with the warm-up activity. Example 1, given the numbers, you have these numbers, list the rational numbers, irrational numbers, and real numbers. Let's start with the definition of rational numbers, right? You might remember we had a chapter called Rational Expression and Equations. Rational, in general, is just fractions. So that's how you can understand it. So rational numbers are just fractions, or any numbers that you could write as a fraction. What kind of numbers you could write as a fraction? Of course, you have fractions, right? There are fractions. You can also have integers, because integers are just fractions that have integers over 1. That's the form. And then in terms of decimals, it's not all of the decimals, it's only certain kind of decimals. So what kind of decimal? You have terminating decimals. Terminating decimals. So let me write down the different type of numbers. So we have fractions, integers, terminating decimals, and then there's also repeating decimals. And these are common categories of rational numbers that you will see. So let's use this to list out all the rational numbers from the list. The first one is -4. It's an integer. It's definitely a rational. You could write that as -4/1, which is a fraction. So by definition, that's a rational number. Second one is negative radical 7. Negative radical 7 we cannot write as a fraction. So some of you might say, what about negative radical 7/1, right? No, this is not a proper fraction. So by definition, what kind of fraction is? Fraction is that you have m/n, where there are no radicals in either of those two parts. So that's how we consider as a proper fraction in this case. So that's why the second number right here is not a rational number. Next one, 0.5 and repeating. So this little bar that you see right here represents that we are repeating this digit 5. So if you write down the decimal, it will be 0.55555, and then this 5 keeps going forever. And because that's just going forever, we put a little bar above that digit to make it simple for us. So we know 5 is repeating. And by what we categorized earlier, repeating decimal is a rational number. So let's write that down right here. And if you're curious how you could convert this to a fraction, let me know. I can show you in person. Next number is 7/3. 7/3 is a fraction, so absolutely rational number. Next one is 3. 3 is an integer. Yes, that's a rational number. Next is radical 81. Radical 81, is that a rational number? And you might think about negative radical 7 that we encountered earlier and say, no, it's not. But some radical numbers, like this one, radical 81, can be simplified. What is radical 81? It's 9, which is an integer, which means it's also rational. So let's put that down. And then the last one is radical -16. Radical -16, if you remember, before this handout, we keep saying that this is not real, right? It's still not real today, so nothing's changed. And since it's not real, it cannot be a fraction. And thus, it's not a rational number. Number 2, irrational numbers. Irrational numbers, so what are the definition, right? Since it's the opposite of rational numbers, the definition would just be any numbers that cannot be written as a fraction. But of course, it has to be real first. So real first and then irrational. So any real numbers that cannot be written as a fraction, that will be the irrational numbers. And we have a few numbers that we already categorized as rational numbers. So let's just see the ones that we didn't select. The first one is negative radical 7. This one we didn't select earlier because it cannot be written as a fraction. And this is real, so that means it's irrational. And then there's another number that we did not use earlier, which is the last one, radical negative 16. So for this one, we said it's not real, which means it cannot be rational or irrational. Rational versus irrational, there are differences, but both of them must be real. And that comes to number 3, real numbers. So what are real numbers, right? Real numbers are numbers that you can see, you can mark, you can identify on a number line. And I would say you can identify all of these numbers, or you could find all of these numbers on a number line, except the last one. So let me copy all of the numbers. It doesn't matter if you have a terminating decimal, non-terminating decimal, fraction, integer. You are able to find them if you zoom in enough. But the last one, radical negative 16, we don't put that there, okay? Because it's not real. We're going to define it today. So that's why we have this warm-up activity. It's just for this number. The whole handout is just for that guy right there. Let's look at the definition. Section 2 is evaluate the square root of a negative number. It will also have this little definition right here. The imaginary unit I is the number whose square is -1. That is, if you square I square, you get -1. And based on this, we can define that for a positive real number b, if you're doing square root of -b, like square root of -16, it's simply square root of b, the number without the negative sign, multiplied by I. So that's why I is just the imaginary unit. So I want to add another expression to the handout right here. So I want you to pay attention to this equation right here. I squared equals -1. So this is basically the definition of that imaginary unit. But a more useful definition will be if we take a square root of this equation on both sides. So let's do that. I'm going to take a square root on both sides. Before this handout, we couldn't do this, right? Because, the number on the right-hand side is a negative. We don't take a square root of negative number. But today, we are able to do that because we defined a new category of numbers, which are called imaginary numbers. And those numbers are specifically for this situation where you are taking a square root of a negative number. So if I take a square root of both sides, I will get I on the left-hand side, right? And on the right-hand side, I will get square root of -1. So I'd like you to write down this equation right here. This is actually a very important equation in my opinion, which will help us solve so many problems on this handout. All right, now let's look at the second equation right here. So the second equation, this one, is a generalization of what we need to do for square root of -1. So how do you get this? I'm going to write down some deduction on the right hand side. Starting with the square root of -b, how do you split it, right? So again, it's about splitting. What I like to do is I like to first split into square root of b and square root of -1, because that's how you get -b. It's b times -1. You do that splitting. And then notice the magic. Actually, it's not magic. It's just a substitution. So we have square root of b. That's just square root of b. And then we also have square root of -1. What is square root of -1? It's I. We just got this equation right here. Square root of -1 is I. So we don't write square root of -1. We write I. And this makes this expression imaginary. Because of the letter I, yes. Also, because of this definition of I, what it actually entails is you're taking a square root of -1. And that basically concludes how the imaginary number will affect our answer in this chapter. Let's do some practice, because I know that if it's your first time seeing this, you might be confused. Example 2, write each expression in terms of I and simplify if possible. And I highly recommend the way you do it is you split the radical expression like I do, and then you do a substitution of I, okay? For example, square root of negative 81, first split, right? I'm gonna do square root of 81 and square root of negative 1. It's always going to be this, you know, if you see a negative number, you just do the positive number times negative 1. That's how you split. And then you do the simplification. So square root of 81, 81 is a perfect square, which will give you 9. And square root of negative 1, use the definition, I. So that will be the answer. Oh, let's change the color back to yellow. So the answer is simply 9i. 9i. I'd like you to practice negative square root of negative 36 on the right hand side. And then when you finish, you could restart the video. Okay, so for this one, you're going to split as 36 and negative 1. Hopefully you did that. And this will lead to 6i. Moving on to number 2. Number 2 is square root of negative 5. So you do the same split. You have square root of 5 and square root of negative 1, because that's how you get negative 5, from 5 times negative 1. And then we do the simplification, right? So square root of 5, it's already simplified. We can't do anything other than just rewrite it. And square root of negative 1, by definition, it's I. So this one simplifies to square root of 5i. Make sure that your I is not inside the radical, it's outside, okay? And then I'd like you to finish the right hand side, use it as a practice. When you finish, you could restart this video. Okay, so for this one, we're gonna split into 3 and negative 1, just like before. And then radical 3, we cannot simplify anymore, you just write it down. Square root of negative 1, we put I there. So it would be square root of 3i. Okay, number 3. Number 3, this is square root of negative 18. So I'm gonna do the splitting as well. First, we have square root of 18, square root of negative 1, right? It's the same strategy. And then simplify each of them. So square root of 18, we did this before, which requires you to further split it. I'm gonna split it into 9 and 2. And then square root of negative 1, you do the substitution of I. And this simplifies to 3 square root of 2i. So there are 3 parts of your answer. 3, radical 2, and then at the end, you have I. And make sure that your I is outside of that radical sign. And I'd like you to use the right hand side, square root of negative 27 as a practice. Pause the video. When you finish, restart it. Okay, so I'm going to split this as square root of 27 and square root of negative 1. Simplify each of them. For 27, I'm going to do 9 and 3. So square root of 9, square root of 3. For square root of negative 1, I'm just going to do I. And this leads to 3 square root of 3i. Okay, and then we have a little sentence right here, which is very easy to be ignored. It says, a complex number is of the form a plus bi, where a and b are real numbers. Let's highlight this piece, right? Which is the a plus bi. A plus bi is the form of a complex number. And then there are different situations of this expression, which is summarized in example 3. So let's take a look at this. It's called a complex number for a reason, because this expression includes 2 parts. You have a, which is the real number, right? This is the real part. And then you have the b times I. So remember I, it's imaginary. So this piece is imaginary. And then you have real plus imaginary, which makes it complex. Some situations, you might just have one of the parts. So let's take a look at example 3. We have a plus bi. The first condition is b equals 0. So if b is 0, our expression will be a plus 0 times I, right? If it's 0 times I, remember what I is. I is square root of -1. 0 times that will give you 0. So this is simply A. And what is A? A is a real number. How do you know? It's given in that sentence above. If you read it right here, A and B are real numbers. So we know A is a real number. Second condition, B is not 0. If B is not 0, our expression is just A plus BI. You know, just A plus BI. And in this case, it will just be a complex number, because that's exactly the form of the complex number. And of course, you might say, what happens if A is 0? So that's the third condition. If A is 0, we have 0 plus BI, and that simplifies to BI. What is BI? It's pure imaginary. Or you could just say imaginary, because it doesn't have the real part anymore, which is represented by A. Our A is 0. So here are the 3 kinds of complex numbers that you might see starting this handout. Let's move on to the second page. So second page, we have the 4 operations of complex numbers. Let's start with the simpler ones, which is adding and subtracting. So adding and subtracting, personally, I think it's a little bit easier because it's very similar to how we simplify algebra expressions by identifying like terms. And same thing here, we're also identifying like terms. So how do you identify? You use this form right here, A plus BI. So the real parts, you could combine them. And then the imaginary parts, you can combine them. That's what I mean by combining like terms. Let's start with example 4. So we have radical -8 plus radical -32. It's a negative everywhere. We're going to do splitting first. So I'm going to split into square root of A, square root of -1, plus square root of 32, square root of -1, right? So this is the strategy that we have been using. I recommend that you do the same thing here. And then we simplify each of them and then do the substitution, right? So square root of A, I'm going to split into 4 and 2. And then square root of -1, it's just going to be I, using the definition. Plus square root of 32, I'm going to split as square root of 16 and square root of 2. Because 16 is the largest perfect square that goes into 32. And then we have this I substitution right here for square root of -1. And this leads to 2 radical 2i plus 4 radical 2i. Make sure that your i's are outside of the radicals. And now we can combine these two, because we do have 2 radical 2, 4 radical 2. They are like radicals. They have the same radical parts, which can be combined. So that's 6 radical 2. And don't forget about the I. So here, in order for you to make sure that you are able to combine them, you don't just check the radicals, right? You also need to check the i's. They both have i's. And that's how you know that you can combine them. Let's highlight the answer. All right, I'd like you to use practice 2, number 1, on the right-hand side as a practice. Pause the video, try your best, and then when you're done or when you need some help, you could restart this video. All right, so I'm going to do this one along with you. Split, I'm going to do square root of 27, square root of -1, plus square root of 48, square root of -1. And then keep splitting. 27, we have done this multiple times now. It's 9 and 3. Square root of -1 is I. Plus 48, we also have done this multiple times. I'm going to split into 16 and 3. And then square root of -1 is I. Keep going. The first one, square root of 9 is 3. And then you have radical 3i. Plus square root of 16 is 4. And then radical 3i. And now we can combine these two because both of them are purely imaginary and they have the same radical parts. Combine them, we get 7 radical 3i. And let's box this. Okay, number 2. Example for number 2. Now we are adding these two expressions. So remember, these two are complex numbers. You have the real part and you have the imaginary part. So when you are adding or subtracting complex numbers, you simply subtract or add the corresponding parts based on whether or not they're real or imaginary. As a beginner, you could do some labeling, right? So for example, 2 and 4, they are real. So I'm going to highlight them. And then the 7i and negative 2i, they are the imaginary part. You could highlight them differently. So when you do the operation, you will do them separately. The main operation in the middle is plus. So I know that I'm going to add the real part. And then I'm going to also add the imaginary part. So this will be what I have, right? 2 plus 4 plus 7i minus 2i. I simply switch the order a little bit, and now I can add them. So 2 plus 4 is 6. And then 7i minus 2i is positive 5i. And this will be my final answer. On the right hand side, let's do this one together because this one is subtraction. You might have some difficulty with this one. So for this one, when you subtract, you're going to do the same thing. You're going to subtract the real numbers and subtract the imaginary numbers. Let's highlight the real part. Real part is 4 and 2. So you're doing the subtraction of these two. You could write it down. It's 4 subtract 2. And then the imaginary part is 3i and negative 6i. And remember, we are still subtracting. So what you're doing is 3i subtract negative 6i. So notice that there are two negative signs right there. If you have two negative signs, you have to put a parentheses. Alternatively, you could also make them positive. So alternatively, I could also rewrite this as 3i plus 6i because double negative becomes positive. And then in the middle, don't forget, it's going to be plus because you're still having the form of a plus bi. If you remember the complex number, a plus bi. So the operation between the real and the imaginary is a plus sign. So that's why I put a plus sign right there. And now let's simplify this. 4 minus 2 is 2 plus 3i minus negative 6i or 3i plus 6i, that's 9i. So the answer to this one is 2 plus 9i. Okay, last section is multiplying and dividing complex numbers. We're going to start with multiplication. For multiplication, I recommend you do the area model as well, like we did before. So I have been using area model a lot in recent videos, and I just feel like it's a good way. So first, let's do a box, right? I'm going to do a box. And then I'm going to divide the sides into two parts. This is because we are multiplying two complex numbers. So you have the real and the imaginary, two parts. And let's also write down the numbers. So for the first complex number, it's 5 and then negative 3i. So those are the two parts. And for the second complex number, you have negative 1 and negative 2i. Okay, so write that down. And then we're going to apply the area model, multiplying the two numbers in each box to calculate the area. So 5 times negative 1, negative 5. 5 times negative 2i, negative 10i. Negative 3i times negative 1, positive 3i. And then negative 3i times negative 2i, 6i squared. So far what you're doing is very similar to what we do before with variable x, you could just treat I as x and then do the operation as you normally do. But because we have I, you have to do one more step, which is the last box right here. I'm not sure if you still remember something about I squared. So let's go back to the first page. Where is it? It's right here, right? It's right here. Let me get rid of the square root. So you see the equation a little bit better. This equation right here, I just highlighted. I squared is -1. So this is something that you have to remember because it's just the definition of the imaginary unit I. We have been using the second equation right here, right? We have been using this one. I is square root of -I. But when you multiply or divide complex numbers, you also need the first one. I squared is -1. So let's do that replacement right here. We have 6 times -1, right? What is that? It's -6. Okay, so there's no I squared anymore. If you have I squared, always replace that with -1. You could write that down if you want. So, always replace I squared with -1. And chances are you probably need parentheses. So I'm just going to add parentheses right there. Like right here, multiplying 6 by -1, make sure you add parentheses. And you get -6 for the last box. And after that, we're going to add all of them. So now I'm going to say equals, and I look at my box. I add all of the numbers. And the way you add it will be do it diagonally because -5, -6, these are real. You could add them. That will give me -11. Feel free to use your calculator. And then the other diagonal, these two are the imaginary part. It's -10i plus 3i, so that's -7i. And we're done. Let's highlight this. So as you can see, the amount of work is simply that box. And once you have the box, you just add it diagonally to get the final answer. And just make sure that your final form is in this form. A plus bi. So we like to have the real part first and the imaginary part next. Let's use the practice 3, number 1 as a practice. Pause the video. When you finish, restart. Okay, so for this one, I'm going to give you the answer, but if you apply the same strategy that I did with the box, you should get the same answer, but you could also do FOIL. The final answer is 6 plus, actually no, it's not this one. The final answer is, actually it's a number, it's 41. Okay, let's move on to number 2. Number 2, this is also complex numbers. You might not see it, but for those who do see, this is because we have square root of a negative number, because this will give you the b times I part. So this is the same as the previous one, but it is a little bit harder. We will see why that is the case. And the way I recommend is that how you do these kind of problems is you want to rewrite this expression into something like this, something like the previous problem that we did, so that you want to simplify so that the I is there in the expression. With the presence of the I, you will have an easier life for solving these problems. So let's give it a try. I'm going to start with the first one. Actually, let's write the work somewhere else, right? Somewhere else. So you're going to start with simplifying the two numbers. We have square root of -12. Split it will be square root of 12 and square root of -1. And I'm going to split 12 to 4 and 3. Square root of -1 is I. So this is basically what we did on the first page. You just do it right here for each of the numbers. And this will give me 2 radical 3i. And then we have one more imaginary part, the square root of -48. Simplify it, so it's 48 and -1. which is 16 3i. So radical 16, radical 3i. And that leads to 4 radical 3i. All right? And then once you have this, our expression now is clear. I'm going to do the box. So I'm going to do a box right here. Divide the sides into 2 because we have the real and the imaginary part. Write down the numbers. So we have 4. If you have trouble, we could rewrite the original expression. So it's 4 subtract square root of negative 12 now is 2 radical 3i times 3 subtract square root of negative 48. Now it's 4 radical 3i. Let's put these numbers in the box. I'm going to use green. So it's 4 negative 2 radical 3i, and then 3 negative 4 radical 3i. All right, and then I'm going to apply the area model to multiply the 2 numbers in each box. 4 times 3 is 12. And then 4 times negative 4 radical 3i, that's negative 16 radical 3i. And then negative 2 radical 3i times 3, negative 6 radical 3i. And the last one, you have to be a little bit careful. Negative 2 radical 3i times negative 4 radical 3i, this will give me positive 8, and then positive 3, and then I squared, which is negative 1. But let's write down I squared first. So this is 24i squared, which is 24 times negative 1, and that is negative 24. Okay, and now we can add these numbers diagonally to write the final solution. Starting with the real number parts, it's 12 and negative 24. So you add them, it will give you negative 12. And then for the other diagonal, it's negative 16 radical 3i, negative 6 radical 3i. So if you combine them, we get negative 22 radical 3i. And the final answer in this case will be negative 12 minus 22 radical 3i. All right, I'd like you to use the right-hand side as a practice. Pause the video. When you're done, you could restart. Okay, so for this one, I'm going to guide you through because this is slightly more complicated. You're going to start with simplifying the numbers. So I'm going to use this color. We have negative 8, right? Negative 8. I'm going to split into 8, negative 1. And then square root of 8, you could split into 4 and 2. And then square root of negative 1 becomes I. So this simplifies to 2 radical 2i. The other number, square root of negative 18, split into square root of 18, square root of negative 1. And for 18, we're going to split into 9 and 2. Square root of negative 1 is I. And that gives you 3 radical 2i. And now our expression, let's rewrite that. It's negative 2 plus 2 radical 2i times 3 minus 3 radical 2i. And we can do a box. I'm going to put the box here. And divide the sides into 2. And then you write down the real and the imaginary. So the first one is negative 2, and then positive 2 radical 2i. The second number is 3, negative 3 radical 2i. Okay, and we set it up. We're ready to multiply. Negative 2 times 3, negative 6. Negative 2 times negative 3 radical 2i, that's positive 6 radical 2i. 2 radical 2i times 3, that will be 6 radical 2i. And finally, negative 3 radical 2i times 2 radical 2i. Make sure you multiply the numbers correspondingly. So you will do negative 3 times 2 first, that's negative 6. And then negative 2 times negative 2, that's 2. Square root of 2 times square root of 2, that's 2. And then we have I times I, which is I squared. As a beginner, you could just write it as I squared, but you should note that we're going to replace it with negative 1 later. So this is equal to negative 12 times negative 1, which is positive 12. Okay, and now we can add the diagonally to write the final solution. Starting with the real part, it's negative 6 and positive 12. That leads to positive 6. And then the other diagonal, we have 6 radical 2i and 6 radical 2i. If I add them, I will get 12, positive 12 radical 2i. Just remember that in the middle, it's always going to be a plus. If your imaginary part is negative, then you don't need the plus. You just put the negative sign in the middle. But for now, since our imaginary part is positive, I'm going to put the plus in the middle, and this is our final answer. Okay, so we're going to move on to number 3. Number 3 is division of complex numbers, a plus bi. And for this one, we're going to apply something that we discussed recently, which is about the rationalization of radical expressions. You might remember we use something called the conjugate. And it's going to be very similar here. This is because I is basically a radical number, right? It's radical negative 1. So if you want to simplify expressions like this, we have to rationalize the denominator, getting rid of that radical sign. And we're going to use the conjugate. So what's the conjugate in this case? The denominator is 5 plus 2i. Remember the conjugate in the form of a plus b and a minus b. You keep the two same numbers, but you replace the operation in the middle, do the opposite, the inverse. In this case, we're multiplying both the top and the bottom by the conjugate of 5 minus 2i. So remember, it's always about the bottom, it's never about the top. 5 minus 2i, the conjugate will be 5 plus 2i. And then you can do the same thing on the top, 5 plus 2i. Very good. And now let's carry out the multiplication. So this is going back to the previous two problems that we did, right? We're multiplying the complex numbers. I'm going to do the denominator first. Because the denominator, we can use a formula if you remember. It's in the form of a minus b times a plus b. So it's simply a squared minus b squared. And I'm going to square the two numbers that I see. So the first is 5 squared, that's 25. And then minus the second number squared. So that will be 4i squared, right? 4i squared. And you could just keep it like this for now, because later on we're going to do replacements. And then on the top, you could do a box, which is recommended. So I'm going to do a box. Let's get rid of this. Do a box. And then I'm going to divide the sides into 2. And then write down the numbers. So on the top, we have 2 positive 5i. And the other number is 5 positive 2i, and then we're multiplying this. Let's multiply and write down the parts. So 2 times 5, 10. 2 times 2i, 4i. 5i times 5, 25i. 5i times 2i, 10i squared, which is the same as 10 times negative 1, and that's negative 10. Once you have these four numbers, add them diagonally. We have been doing this for a while. The first diagonal is the real part, so this is 10 and negative 10. They cancel out, it's just a 0, so you don't need to write anything. And the other diagonal will be 4i and 25i. So I add them, I get 29i. Let's write that. Looks like the top is pretty simple, it's just 29i. Next, we're going to replace the I square in the bottom with -1. So this will be 29i over 25 subtract 4 times -1. And that denominator will give you 29. Or, if you do -4 times -1 is +4, 25 plus 4, 29. So this expression becomes 29i over 29. 29 is a common factor. We can cross it out. We get I as the final answer. All right, I would like you to use the right-hand side as a practice. Pause the video, and when you're done, you can restart. Okay, so for this one, I just want to guide you at the beginning, but you're going to finish the rest. So the conjugate you're going to multiply will be 6 plus I, because the original denominator is 6 minus I. You just do the conjugate of that. And then you will multiply both the top and bottom by 6 plus I. Once you do that and simplify, going through the same process that we did earlier, you should get I as well. So that's the final answer. Okay, number 4. Number 4 is much easier because number 4, if you look at the denominator, it's just pure imaginary. We don't have the real part. It is still a complex number, but I would say less complex because it's purely imaginary. If it's purely imaginary, the way to rationalize this expression will simply be what we did before for the radical. If you only have one radical in the denominator, we multiply both the top and bottom by the same radical. So same thing over here. We simply multiply both the top and the bottom by I. Let me rewrite this. So multiply the bottom by I, multiply the top by I. Whatever you do to one side, you do it to the other side. And why do I do that? Is because when you multiply I by itself, you get a real number, which is -1. I squared equals -1. And that rationalizes the denominator, which is what we want. Let's multiply that. On the top, I can distribute the I, so I'm going to have 3i plus 3i squared. Okay, and the denominator is 2i squared. When you do operations with I, just treat this I as like a variable x. But this variable x does have meaning, so you do have to do another step after you simplify it. The step that we're about to do is what the I square means. I square is -1. Let's replace that. So we have 3i, right? And then plus 3 times -1 over 2 times -1. What I did right here is I replaced I squared with its definition, -1. And then for the final answer, the textbook does require you to rewrite in the form of the complex number, which is a plus bi, so you should have a real part and a complex part. For this one, I'm going to rewrite the top, so you will get -3, that's the real part. And then imaginary part is positive 3i over the denominator, which is -2. And I would say this is good enough, but if you want to make it even better, we're going to divide the top by the denominator -2. So -3 divided by -2, that's positive 3 over 2. And this is the real part of this complex number. The imaginary part will be 3i divided by -2. So that's -3 over 2i. And now we have this form, a plus bx, which is the complex number form. And that's the answer preferred. That's the preferred way to write the answer. And I'd like you to use number 4 on the right hand side to practice. Pause the video. When you're done, you can restart. Okay, so for this one, it's the same thing. We're going to multiply both the top and the bottom by I. And then if you simplify correctly, hopefully you did, you should get this answer. Okay, finally, we have one last problem left. So this problem is about raising the powers of I. I is a very magical number. And just remember what I means, right? The definition is on the first page. It's an imaginary unit that we use to represent a number that we could not represent before. It's imaginary because you cannot find it on the number line. And we are going to do this practice to find a pattern for the powers of I. So how do we do that? Let's start with the first power, right? So I to the first power, it's just I. Nothing interesting there. And then let's do the next power, I square. What's I square? I square is just I times I, right? Or you could use the definition, it's -1. We have been using this a lot. And then let's keep raising the power. I cubed. What is I cubed? I cubed is simply, you could say I times I times I, but I would say a better way to do that is it's I squared times I. Why do I do that? Is because we have a result for I squared. It's -1. So this simplifies to -1 times I. It's -I. And then you now should have an idea how you could do I to the fourth power, right? I to the fourth power will be I cube times I. And then we have I cubed that's just computed, which is -I. So this is -I times I. And that's -I squared. What is -I squared? So here you have to be a little bit careful. Keep the negative sign and replace the I square with -1. And we have a double negative situation going on, so you need parentheses. We have -1. What is that? It's +1. And that's I to the fourth. So far, everything is different. We don't see any pattern yet. So let's keep going. Next will be I to the fifth power. So how do you do I to the fifth power? We use the same strategy, right? It's I to the fourth times I. What is I to the fourth? It's 1. We just calculated that. So it's 1 times I. What's 1 times I? It's I. And then if you don't see the pattern now, it's okay. We could keep going. But for those of you who see the pattern is already here. Let's just do one more. Next one is I to the 6. I to the 6, using the same strategy, it's I to the 5th times I. And then we just find out I to the 5th is I. So it's I times I again, which is -1. And then I think you probably see the pattern now. If not, I'm going to point it out to you because I don't want to do any more of this. You have I, -1, -I, and then 1. That's the pattern. Because if you see the next one, it starts with I again. And then -1. So you guessed it. The next one will be -I and then 1. So you have this cycle of, let's write down the cycle. So you have this cycle of I, -1, -I, and 1. This is the cycle. Starting with the first power. So every 4 powers, the powers of I will follow this pattern. And how do you use this pattern, you might ask? We can use this pattern to determine the value of any power of I without doing this calculation again. For example, the power of I to the 92th, right? I to the 92. All you need to do is just find out how many cycles did you go through in these 92 powers. All you need to do is do a simple division of 92 divided by 4. Because each cycle, it includes 4 powers. I want to see how many 4 powers are there, how many cycles are there in this expression, which is I to the 92. Let's divide by 2, and this number is actually divisible. So if you divide it by 2, you get 2, that's 8, and then 12, that's 3. Or you could use your calculator, you get 23. There's no remainder. The remainder will tell you specifically which part of the cycle is the answer. And we got 0, which means it will be at the very end of the cycle. So it will be end of the cycle. It went through 23 full cycles by raising I to the 92nd power. And that's basically what that is. So what is the value of the end of our cycle? It's this number right here, which is a 1. So that's how you know I to the 92th is 1. And that means you might ask, right, what is I to the 93? That will be the first value in the cycle, because you're starting a new cycle again, which is I. So that's how you could use this pattern to find any powers of I. And that's basically this handout. Thanks for